Good afternoon. Yeah, my name is Pini, and I'm from cinq, which is a company that is specifically focusing on sustainability, not particularly in IT in general, but this talk is about sustainability in IT. So first, a question, not an app you can answer directly. What do you think how bad bananas are in terms of sustainability and carbon emissions? Just guess. If you bad, terrible, nice, like okay-ish. Not that great. Okay. It's always like that. That's always the answer I get on this question. And I'll tell you more at the end. So, why climate change? Right, so is it a real thing or not? I assume you think it is because you're here. I'm not going to argue about that. You know, there's plenty of scientists and they do a great job convincing people. But generally speaking, there is increase in average temperature on Earth, right? And generally speaking, it's not even the question if the temperature is rising, but more like how bad it's going to be. Right? We agreed as majority of the countries in the world, we agreed to limit the climate change to 1.5 degrees in Paris Agreement about a decade ago. And we already almost passed that 1.5 degrees. So the question, how far is it going to get? Right? If it's 2 degrees, it's like manageable, 5 degrees is quite bad, and 8 degrees is absolutely terrible. So, and obviously the impact on climate change is because of carbon equivalent or greenhouse gases emissions. So, and they're still on the rise, right? So we agreed to limit them, but actually it's still getting worse and worse, right? We are emitting about 56 billion tons of carbon equivalent. It's not just carbon, it's other gases too. And generally, the worldwide, it's still growing. This drop, which one is it, do you think? It's COVID, yeah. So, and it dropped about 5% and then picked up back within a year or two. So, and we basically stopped traveling, right, for entire year. And the effect of that was about 5% decrease in carbon emissions. And we picked up back. So still, it's going up. The good news, though, is that in developed countries like US or European Union or any developed countries, it's going down. Already for about 30, 40 years, it's decreasing. So the carbon emissions are actually on decline. China is also, seems to be at the peak and now started to decrease, but other countries like India or a bunch of others are still growing. So we are still emitting about 56 billion tons of carbon, and it's going up. And we're continue doing that, and the Earth getting warmer. Specifically, Netherlands is on decline, because we're in Netherlands, right? So it's, and you can see all kind of drops during the wars and other changes and geopolitical changes. But this drop is not during the war. This is actually real reduce in emissions because of greener energy and all kind of other attempts of the world to reduce the emissions. And of course you can say, you know, the green energy is growing, the green energy is now cheaper than coal and gas, so we just wait until it's all going to be replaced, and why not, right? In reality, our demand for energy is growing not faster than supply of green energy, but the carbon-based energy needs to go down faster, right? So if we reduce the consumption of energy, we can roll out the coal and gas faster. And we still need to increase our investment in green energy. So what the governments are doing, actually quite a lot, depends where though, right? In Europe, there is a lot, right? There's Green Deal, there's an agreement to reduce carbon emissions by 55% by the end of the decade. It's very aggressive. There's the only other places where this happening as aggressively is UK and California. But in the rest of the world, there is not much happening, right? But EU specifically is actually very assertive, and they're doing quite a lot of investment in this. There's regulation, there's something called CSRD and all kind of other things, so the larger companies have to report on their emissions from this year, smaller companies from next year. So there's quite a lot of demand from the companies to reduce their emissions. Because, again, the commitment is 55% by the end of decade across the entire EU on all industries. This is just 6 years from now, right? That's a lot. And also, over time, we will see more and more things like carbon taxes or fines for not reporting or reducing the emissions. So there is quite a lot of pressure from the government to actually do that, especially in Europe. So, okay, this is sort of geopolitics and global, but how we as IT industry, how it relates to us. So this is, if we assume the current consumption of IT services is on this level, we expect in the next 2 decades, the demand for digital services will explode due to AI, general digitalization of all the industries. We will need to build more and more digital capabilities, while carbon emissions have to decline to almost nothing over the same period of time. So the question is how we can continue increasing our IT capabilities while reducing the carbon emissions. That's the real challenge, right? Unless we can decouple our work from carbon emissions, we're not going to be able to do that. Already today, some countries like Ireland forbidding, there is a ban on construction of new data centers. In Netherlands, new data centers struggle to connect to the grid, so there is not enough energy to support further development of IT. And in the same time, the average utilization of the data centers is hardly 20%. Right, so according to different studies, between 15 to 20% average utilization of existing hardware. So we are building data centers in massive numbers. We are increasing the energy consumption and other emissions, while only using about 15 to 20% of the same capacity, right? Everything else is just sitting there and wasting resources. And the reason for that is sort of this shift, to a bit historical context, is we shifted from craftsmanship in the beginning of IT in 60s and 70s. We shifted into this waterfall setup that went from 70s to 90s, where the main goal of that was to basically control development of software. Because in the craftsman, in 50s, 60s, and 70s, it was really difficult to control development of software. Everyone did it in different ways. So the industry said, no, we have to do it right. We have to have architects, proper processes, predictability, control. We have done that, but we drove out the innovation. So in beginning of 2000s, we shifted to agile, and the main point of agile is to allow us to innovate as fast as possible. So quick cycles, we are talking about this for the last 20 years. The thing is that agile methodologies, they are optimizing for productivity of developers, right? Everything is secondary to the speed of delivery of a feature, right? We became sort of feature factories, right? It's super important to deliver a piece of functionality to the customer, to create value to the customer, and everything else is secondary. And if I have a problem with hardware, we buy more hardware. Right? If something is not working too well, right, we provision a bit more, a bigger VM, a second VM, more memory, and it sort of works out. And the result is 80 to 85% waste. So there are few ways to do it wrong way. Yeah. So mostly it's about talking and not doing. And I'm sure you have seen this around, things like, so it's called greenwashing, basically saying that we are doing a great job without actually doing anything. For example, one way to do it is to say, we reduce our emissions, our direct emissions, from our offices or from employees or the things that we are doing ourselves, but whatever our suppliers are doing is not our problem, right? One way to reduce emissions is to move some of the work to the suppliers and say it's not my problem, right? It doesn't change anything, right? It doesn't change the amount of emissions generated. But in the nice report, you can say, okay, I sold the factory to a third party to China, right? And from that point, it's not my emissions anymore, so it's not my problem. So my emissions went down 20%, right? That doesn't make any difference. There's a lot of ways to tell people that you are reducing emissions without actually doing that. The other not so good way is carbon offsets. The principle of carbon offsets is that you, like when you buy a flight ticket and you can pay a few euro extra and then they plant trees or do something with it. Now, it's not a bad concept, right? It's a reasonable concept. And it's not something that should stop, but majority of the offset programs are actually absolutely terrible. They're not doing anything, right? They're saying we're not going to cut down the trees, but in reality, they're using the same tree 10 or 20 or 50 times. And at the end, it's not the point. It's not a tool to allow you to continue emitting the carbon emissions, right? It's a tool to offset the remainings of like something that's very difficult to stop emitting. There is a very nice video from John Oliver. It's funny and very educational, 20-something minutes. I very much recommend you to watch it if you are interested in this. And he tells the full story of offsets. At the end, instead of helping to save the planet, they become sort of a tool to escape responsibility. So, going again deeper into IT, what we need to consider when we talk about carbon emissions is not just the energy that we are consuming. So basically, there are three scopes of carbon emissions. If we are the company, if my company is reporting on the emissions, there are three scopes. Scope one is direct emissions from actually burning carbon fuel or something like that. Let's say you have a car, you drive the car, it burns petrol, that's scope one. Scope two is energy consumption, right? So you consume power from the grid, they burn oil or gas or something like that, and that's scope two through electricity. And scope three is everything else. So it's the supply chain. So when you buy from, let's say in IT, if you work on Amazon, then whatever is in Amazon is scope 3. So that's your supply chain. It doesn't belong to you directly, but you still consume their services and they are emitting carbon for you. So you still need to report it. Right? So scope 1 is direct emissions, scope 2 is through electricity, and scope 3 is everything else. It's everything you consume and everything you sell. So then again, if we go to greenwashing, if you say, I only need to report on scope 1 and 2, so whatever is running in the cloud is not my problem, that's why I don't need to deal with it, right? Then that's cheating, right? So, and when I say everything, it means everything including the data center building, the cooling and heating of that, the water, everything should be included in the emissions, right? It's not just about electricity or burning fuel. And the way to calculate that, or the three elements that are included in carbon emissions are energy, and how much energy we consume and what's the energy efficiency, hardware efficiency. So when we use, in IT, we use a server, right? There is embodied carbon in a server. So that's the carbon that was emitted while producing that device. So hardware efficiency means how many servers do you use? Can we reduce the number of servers, or can we do the same work with less devices? And carbon awareness is the carbon intensity in the grid, basically, right? So, for example, if you use, if in the grid there is solar energy, then there's potentially greener energy during the day and less green during the night, or things like that. So these are the three elements: energy efficiency, hardware efficiency, and carbon intensity or carbon awareness. And the way to calculate it is suggested by Green Software Foundation, which is part of Linux Foundation. So that's foundation that defines the standard in the IT industry around green software. So it's basically energy multiplied by intensity of the carbon intensity of that energy plus the embodied carbon per unit of calculation. So eventually where we want to go is to get to the point that we calculate per unit of software. Let's say your Twitter, right, or X, yeah? So what you want to get is how much carbon emissions per tweet, right? And you want to tell the consumer how much per unit of consumption. And that becomes their scope 3. So that's the way to calculate. Also, if you think about, let's say, home appliances, you see this A, B, C, D ratings for home appliances. Eventually, we want to get to similar situation in software. So the pieces of software need to become sort of graded A, B, C, D. So how much emissions they produce per unit of consumption. And we also need to remember that this is not all or nothing, right? So of course, we want to reduce emissions, but it's a journey, right? So this is another very nice piece of content from Green Software Foundation, which basically says that it's a maturity matrix for sustainability in IT, right? And of course, we all want to be here, but then we look there and we say, like, that's too difficult, so I won't even start. That's not the point, right? The point is to start from the beginning and take the 4 steps and then gradually get there, right? So it's not about being entirely green. It's about starting the journey. Yeah, and then going back to the historical context, so this movement to agile, basically, the way we operate, the way we build software creates all this waste, right? So basically, the reason we are in this situation is because when we had waterfall, so this is the product life cycle. Like, it starts from development, introduction, growth, maturity, and decline, right? This is standard product life cycle. What happened with waterfall is that waterfall is very good for stable, mature systems. They are predictable, they are stable, and then when we move to agile, we are solving the problem of innovation in earlier stages of development. Right? The problem is we now apply agiles throughout the product life cycle, including for mature, stable, scaled systems. So it means that in early stages, when the focus is supposed to be on innovation and quick feedback, the waste is actually not important because those systems are not highly scalable yet, there's not too many users, and it's very important to get quick turnaround of different features. The problem is, it's the opposite for mature systems. It's all about stability. So if we think about lean versus agile, so lean is like original Toyota production system, it's not agile at all, right? It's not about changing direction. It's about producing the same thing over and over again at minimal cost and as quickly as possible, I guess, right? So what we really need is to adjust our methodology to the stage in the life cycle of the product. And as product matures, we need to shift away from things like Scrum and quick turnaround and a lot of waste and productivity-driven metrics to things that are more cost-driven metrics or quality-driven metrics. So things like OKRs, where we define business requirements and we define data-driven key objectives and key results, yeah? So objectives and then key results to measure the achievements. And then start measuring things and adjust our development processes according to the maturity of the product, right? Because when I hear things like sprint 200 for a certain product, it means there's not much innovation in that product. Unlikely there is a lot of innovation, right? When it's 200 sprints, it means that the product is likely very mature and it doesn't change that much. So it's actually much better to focus on quality of that product rather than innovation. So, and there are already methodologies that are supporting this kind of way of working, like SRE. Yeah, so SRE is focusing on specific metrics like latency, traffic, so those are stability and quality metrics. Similar metric is FinOps, right? It's cost. Similar metric could be sustainability metric based on software carbon intensity, right? So what we need is to basically, as we move away from innovation where the waste is actually not important, as we move into scale and stability of larger systems, what we need to do is to focus more on these metrics, on specific measurable metrics and put them as the goal. First we need to define the objectives. Are we still focusing on innovation and getting more customers, or we are shifting into stability and performance? And on the other side, there are DORA metrics, which are more focusing on productivity of the developers, which is still very valuable. But then, again, it needs to be intentional decision. Are we focusing on innovation and productivity of developers, or on scale and performance? And if we are focusing on the scale, then we need to make sure that developers and everyone in the organization understand that what's the impact on the environment? How much carbon emissions are we emitting? We need to measure it and put it as a goal. And those things need to change over time, right? It's totally reasonable to start with more innovation and more waste, right? But when we move into large scale and we are still 80% over provisioning hardware, it makes no sense, right? We need to focus on making sure we're not wasting all those resources. So what are the tools that are available? So actually, there's not that many tools. Yeah, so you can get some information from the cloud, but it's mostly based on cost, right? So if you look into billing systems of all major public clouds, they will give you information based on cost. But this information is typically not very useful for active reduction. So what you want is real-time, accurate reporting that gives you feedback immediately. If you do something, you know how much you are reducing. So one of those tools is Kepler, which is specifically for Kubernetes. Kepler shows the energy consumption by different applications running inside Kubernetes. It doesn't show carbon emissions. It shows them, but in not very good ways. But it actually shows energy consumption. So if you remember, energy consumption is only one element. The other element is hardware consumption, and the third element is actually carbon intensity in the grid. Another tool is Scaphander, which is measuring everything else, everything Kubernetes or not, but it only works on-prem because it's actually connecting to physical hardware and gets this information from directly from there. So it doesn't work on the cloud because it doesn't have access to the hardware. We are also working on a tool called Ether that connects to any monitoring tool, collects the consumption, resource consumption information, CPU, memory, networking, and storage, and converts it to energy, and then later converts it to emissions. It also integrates with Kepler. So those were more infrastructure-oriented tools. But there's also more software development tools like profiling. So what you want to do is potentially is to go line by line and figure out how much emissions different parts of the code generate. So there are tools like that. There are actually a couple of talks around this. One from ING and another from Firefox. But if you're interested, it's actually those are quite interesting talks. Yeah, it's effectively you can get to the point that you can go line by line and see how much energy each line produces, and then see which algorithm works or which algorithm is greener and things like that. So they work in very different ways. ING is Java connected, I think, and Firefox connects directly to physical hardware. Right. And the other side is programming languages. This is typically, people have very strong opinions about that. And in the way it's true, so there is a big difference between choosing the language. If C is 1, then Perl is 80 times less green, right? So more or less for the same functionality, Perl will emit 80 times more compared to C, right? But this is all interesting, but actually, this is a very problematic research, right? Because obviously it depends on the algorithms, on where it's used, productivity of developers, or potentially some of the languages may shift away from interpreter into sort of semi-compiled code. So there are actually many ways to reduce those emissions. One thing that should be clear is that it's definitely not a recommendation to start from this, right? Like, let's rewrite code from Python to Rust, for example. Typically, the process of refactoring itself would cost more than whatever you're going to save. Right. So what we say typically is that there are a set of quite simple actions that you can take to reduce your emissions by 50 to 60% or so, which is basically right-sizing the infrastructure, right? So even before you optimize the actual code itself, there are things like, killing the zombies, provisioning just enough hardware for what you need and not more, dynamic scaling, potentially using correct or better CPU architecture, so ARM is much more efficient compared to Intel. And then the other thing is actually carbon awareness, which is when to run your application. So on one side, it's so reducing or not wasting the hardware. And the other side is when to run the applications. So for example, during the day, there is potentially solar energy or wind energy. So if we measure the carbon intensity in real time, then we can run our loads according to actual carbon intensity. There's also big differences between different countries. So this is just examples. In Sweden, it's 23 at this point. This is from this morning. 23 grams of carbon equivalents per kilowatt hour. In Netherlands is 256, and in Poland 862. Right. So the difference is actually quite dramatic. Yeah. So, but it doesn't mean we all need to move to Sweden or Norway, right? Because if we all do that, then we will overwhelm their green capacity, and then, at the end, it's not what we do, it's how we all jointly affect the world, right? So if we take their green capacity, then they will have to generate it in some other ways. And they're already using everything they have. Or they actually, whatever extra capacity they have, they export to different countries, like Netherlands. And this is an example of embodied carbon for a typical server, right? So again, our carbon emissions coming from energy consumption, which is the amount of energy applications use and carbon intensity in the grid, plus the embodied carbon. So a typical server, like this Dell server, is about 7 tons of carbon equivalent. Now the question is, for how long are we going to use it? Right, so they say it's, how much? It's 17% is the carbon emission, it's embodied carbon, and the rest is actual use, so the energy. But if we extend it to extra year, then we can get more value from the same server and reduce the embodied emissions. So effectively, if we buy less hardware, that's also impactful. Right? For example, Amazon decided to increase their use of their service from 5 to 6 years, which is not just reducing emissions by a lot, it's also saving $900 million. There's another company in France that they figured out that the main thing that goes wrong in the server is the rate controller, physical rate controller. So they replaced it with software rate controller, and then they run the same servers for 10 years. All right, so the way we are, in our experience, basically majority of the saving at this point can happen on infrastructure or platform level. Anywhere between 50+% of the savings can be done just by sort of switching the lights when you leave the room, right? So if you have unused hardware, just shut it down. Because even if you are not using it, it still consumes energy. Right? Just shutting down things that are not used, just right-sizing the capacity to actual need, that's at least 50% reduction. And again, this is 50% reduction that directly translates to cost reduction, not just emissions. Another 20–30% is in optimizing actual software, and the rest, there are all kind of other ways to do it. But the point is that we can actually run the same IT services that we are doing now at about 10 to 20% of the emissions that we're generating now, right? So a lot of what we're doing is waste. And I'm not saying we should shut down, reduce the value for customers. I'm saying just by optimizing the same systems, providing the same value to the same customers, we can be doing it for less than half of the emissions and the cost, if we focus on optimization. So what the focus areas for those who just start in the journey is mostly about learning and measuring, right? So most companies are not yet aware how much carbon emissions they are generating. So there is not enough knowledge and capabilities around this area. So most companies just keep going without much awareness. So those are the two areas that we would recommend to start with. One is knowledge, read, go and see the talks about this, and reporting, right? So start measuring. Although it's not trivial to start measuring, but there are more and more tools like the one that we're building that actually allow measurement. And once you see the numbers, you can make a decision to actually act on it or not. So, back to bananas. So you said it's not so good, right? So actually, bananas are not that bad, right? So a single banana And of course, like every time we talk about emissions, of course, there is no precise number, right? Because it depends in which country it grew, if it was airlifted or shipped by ship. There are all kind of different parameters. But overall, bananas are actually, the way food is measured is basically emissions per calorie. So bananas are actually very good, or quite good. So it's 110 grams of CO2 equivalent per banana. Yeah, and it's about 100 calories, I think. Another example is email, right? So a simple email that goes to spam is about 0.03 grams, so not that much. On the other side, an email that takes 10 minutes to write and send to 100 people, and 99 people spend 3 seconds looking at it, that's 26 grams, right? So if you do that, if you send an email to a bunch of people and they all open it, like you cause them to do something, right? You cause them to do the emissions, right? If you don't have to do it, I mean, it's general bad idea to send emails that people don't need to read, right? Regardless of carbon emissions. Yeah. A typical laptop or phone, it's very comparable. They're about 83% embodied carbon. So actually majority of the carbon is generated while producing the device. It means that if you extend the lifespan of your laptop or phone from 2 years to 3 years to 4 years, you're directly affecting this. You're directly reducing the emissions. This is cycling a mile, right? But the way it's framed is when you cycle a mile, people think it's free in terms of emissions because we are, people. But actually, we are powering this bicycle with food. Yeah. So if we power a bicycle with bananas, it's 40 grams per mile. If we power it with power-lifted asparaguses, it's 4.7 kilograms. Apparently, airlifted asparaguses are the worst. But a cheeseburger is 310 grams. So the point is that beef is from major foods. Beef and lamb are the worst, and then pork. So meats are generally quite bad, and bananas are okay. And a couple of other things is, so cryptocurrencies are about 1/8%. So it doesn't sound a lot, but if we think about this, it's mostly about mining, right? So we're actually spending about 0.1% of total global emissions on crypto mining. We spend about 1% of the global electricity, or 0.25% on public clouds. 1% of global electricity, or 0.25% of carbon footprint. So in general, the IT industry in total is about 4 to 6% of carbon emissions. And if we do nothing about it, it will go towards 10 to 14% by the end of the decade. Right, so it is very much meaningful. If you compare it to airlines, it's 2.5%. So the IT industry is actually generating double the emissions of airlines. So, and I recommend you to read these books. Some of them are more technical than others. Actually, this one is very technical. And it's probably the only one, or one of the very few books that are practical for software developers. The rest are more general knowledge. Yeah, and at the end, if you ask me what to do next, I would say read the book. The Building Green Software, I think, the most appropriate book to read. and start measuring, right? This is the most important thing. You're not going to do anything unless you actually know what's going on. That's it. Thank you.